Hey everyone, and welcome to This Explainer. Today, we're taking a cinematic journey across the globe to wrap our heads around one of the most absolutely crucial shifts happening on our planet right now. We're going to explore how a changing climate is fundamentally rewiring where, when, and exactly how we get our most vital resource, freshwater. You know, it's a fascinating, complex puzzle that goes way beyond simply assuming that things are just getting drier everywhere.
To anchor the stakes immediately. It's so easy to look at a globe and think, wow, we are practically swimming in water. But consider this wild statistic from MIT. 99% of Earth's water is either salty ocean or totally locked away in frozen ice caps and glaciers. That means literally less than 1% of all the water on Earth is actually available fresh water for us to use. Less than 1%. That tiny sliver has to support billions of people, global agriculture, and our entire industrial world. And as you'll see, it is under immense pressure.
Okay, let's dive into this. Here's our flight path for today. We're going to cover 1. The global water cycle. 2. Mountains and dry regions. 3. Tropics and high latitudes. 4. Densely populated coastal zones. 5. Availability versus accessibility. And finally, 6. Managing our water future.
So, kicking things off with Section 1. The global water cycle, a system in overdrive.
Right now, human activity has already warmed our planet by about 1 degree Celsius. And that might not sound like a ton, but it is a massive amount of atmospheric energy, and it triggers this intense domino effect. Step 1, we get those warmer temperatures. Step 2, this heat acts like a giant sponge, significantly increasing the rate of evaporation from our soils, lakes, and oceans. Step 3, that warmer air physically holds more water vapor. And finally, Step 4, all that excess moisture creates totally altered precipitation patterns and incredibly intense storms. The entire global water cycle essentially goes into overdrive.
Moving right along to Section 2, Mountains and Dry Regions, Shrinking Reserves.
In mountainous areas, warming winter temperatures mean precipitation is increasingly falling as rain instead of snow. And whatever snowpack does manage to form, well, it's melting way earlier in the year. To understand the sheer human scale of this issue, let's zoom in on the Himalayas. Almost 2 billion people, 1.9 billion to be exact, live downstream and rely heavily on glacier-fed rivers. These glaciers and seasonal snowpacks act as nature's water towers, right? They store water all winter and slowly, reliably release it during the dry season. But as they shrink, that reliable downstream flow just vanishes right along with them.
And you know, this isn't just a drinking water issue. It is a massive energy issue. Over in the American Southwest, in the Colorado River Basin, a mere 1% decrease in stream flow results in a 3% decrease in hydroelectric power generation. As winter precipitation drops and spring brings these warmer, much drier conditions, reservoirs like Lake Powell decline, which directly cuts into the energy grid. Water and energy are just deeply, deeply connected.
Now looking at Europe, the situation in dry and semi-arid regions is quantified brilliantly by the European Environment Agency using what's called the Water Exploitation Index, or WEI+. Basically, a value over 20% means severe water stress. Look at these numbers from 2023. We've got Spain at 26.5%, Malta at 66.7%, and Cyprus at an absolutely alarming 92.1%. This data really shows how severe seasonal water stress is hitting these countries, mostly driven by dry weather, reduced flows, and super high demand from agriculture and tourism.
But the compounding effects are even more striking when you look at a place like Jordan, which is historically already one of the most water-poor nations on Earth. A Stanford University study actually projects a 30% decline in rainfall and a tripling of drought occurrences by 2100 if emissions aren't reduced. It is essentially a slow-moving disaster unfolding in a dry nation that's also facing rapid population growth. The water is simply vanishing.
Let's shift gears to Section 3, Tropics and High Latitudes, the Paradox of More Rain.
Up in high-latitude regions, thawing frozen ground and melting ice are completely altering the historical timing of freshwater availability. But meanwhile, down in the tropics, we encounter this wild contrast known as the water quality paradox. Now, what's really interesting about this is that more rain doesn't actually mean more usable water. When a supercharged atmosphere drops heavy, intense rain, the soil just can't absorb it fast enough. So instead of gently percolating down to replenish our underground aquifers, it just causes flash floods. These floods completely overwhelm our water infrastructure, washing massive amounts of sediment, agricultural fertilizers, and road petrochemicals directly into our water supplies. Plus, it creates perfect breeding grounds for waterborne pathogens like Giardia.
Which brings us to Section 4. Densely populated coastal zones, the squeeze.
Densely populated coastal zones are essentially caught in a geographic vice grip between rising oceans and falling freshwater resources. Just look at these cascading pressures crushing coastal infrastructure. You've got rapid population growth, which drives the overpumping of shallow aquifers. As all that freshwater is sucked out, rising sea levels push saltwater right inland to fill the void. It's a process called saltwater intrusion. In Florida, for example, as sea levels rise and submerge the freshwater Everglades, saltwater is actively invading the Biscayne aquifer, which literally threatens the primary drinking supply for millions of people.
Let's step back for a macro view in Section 5, availability versus accessibility. So, the crucial point is, to truly understand this global shift, we have to recognize the massive difference between water just existing and water actually getting to your tap. Availability is just the physical presence of rainfall or a river in a given region. Accessibility, on the other hand, means having the infrastructure, the right timing, the storage capacity, and the water quality required to actually deliver it safely to a human being. A region might get plenty of annual rain, but if it all falls in 1 week of massive flooding and gets heavily polluted with runoff, well, it is totally inaccessible for daily human use.
And to put that into perspective, this gap between availability and accessibility is exactly why 2.2 billion people globally currently lack access to safe, readily available drinking water. It is a staggering human crisis, and it's being amplified right now as 21 of the Earth's 37 largest underground aquifers are actively shrinking faster than nature can replenish them.
Finally, let's look at Section 6, managing our water future.
Because the old ways of simply building a bigger dam aren't always going to work when the timing and quality of the water have fundamentally changed, modern adaptation requires a totally combined approach. We have to mix traditional gray infrastructure, like high-tech wastewater treatment plants and desalination facilities, with green infrastructure. This means doing things like restoring wetlands, protecting forests, and building urban rain gardens that naturally soak up and filter water. We're even looking backward to move forward. In India, for instance, efforts are actually underway to revive millennia-old traditions of capturing excess monsoon rainwater and purposefully channeling it underground to store it safely for the dry season.
Before we wrap up, I want to pose this thought-provoking question to you. It really synthesizes the core paradox we've explored today. If warmer air holds more water, and overall precipitation is actually increasing in certain areas, why on earth are we facing an unprecedented global water crisis?
Well, here's the absolute biggest takeaway. Climate change does not simply mean less water everywhere. Instead, it fundamentally changes where the water falls, when it falls, and how reliably it can actually be captured and used. Effective, highly localized water management isn't just a nice environmental goal anymore, it is arguably the most critical challenge of our warming world. As our global tap shifts, the real question is, how quickly can our infrastructure and our habits shift with it? Thanks so much for joining me on this explainer. I hope you found it as fascinating as I did. See you next time.